All right, so today we are going to learn about how to do Lewis dot diagrams. And before you can do a Lewis dot diagram, you have to know about the periodic table. You have to know how to find valence electrons using your periodic table. So that's why I have this picture of the periodic table up, and you should have yours on your phone or a hard copy at your desk. So what we're going to do first is look at what groups we can get the valence electrons for. You cannot use this rule that I'm going to give you with the transition metals, and those are the ones I'm marking out right now. These ones in the middle, these 10 columns in the middle, you cannot use this rule with those 10 columns. So I'm going to mark them out. The rule that I'm talking about is that the number of valence electrons in an element is the same as the group number. Whatever group it's in, that's how many valence electrons it has. So this would be group 1, group 2, it's got a little delay in it. Then this is 3, 4, 5, 6, 7, 8. Ma'am, go ahead. There are also transition elements that we aren't going to deal with right now. Yeah. No, they're all the same, and all in the same section. Most periodic tables number the groups from 1 to 18, but all we did is took out the 10 in the middle, and that gives us 1 to 8. Okay? So anything in group 1 has 1 valence electron. Anything in group 2 has 2 valence electrons. Anything in group 3 would have how many? 3. Group 4? 4. Group 5? 5. Group 6? 6. Group 7? 7. And group 8? 8. Okay, so let's look at some examples of bonding. The one that you are going to see pretty soon, by the end of the class period, is Mg and oxygen. If we put those two together, we need to figure out what kind of compound that's going to form. The way we do that is by looking at what valence electrons are present. Yes, you need to write this down, what I'm writing on the screen now. Just write it at the bottom of your notes or on a piece of paper or something like that. So magnesium. How many valence electrons does magnesium have? Look at what column on the periodic table it is in.
24 through 31.
No. What column is magnesium in?
Oh, 2.
2.
Sorry.
2. So I'm going to put 2 dots to represent my 2 valence electrons. That is a Lewis dot diagram. So when I talk about Lewis dot diagrams, that's all I mean. Put a dot that tells me how many valence electrons the element has. So oxygen. 6. Why is it 6?
Because it's in the 6th row.
Because it's in the 6th column, not row. It's in the 6th column. So 1, 2, 3, 4, 5, 6. Okay? What is the octet rule? You mentioned that in the video we watched just a little bit ago.
You add them.
No, the octet rule means that everything wants to get how many? 8. Very good. Everything wants to get 8 electrons. So oxygen's sitting here with just 6. It would like to have how many more?
2.
2. Well, it looks at magnesium and says, hey, you got 2 electrons. I would like 2 electrons. So magnesium gives its 2 electrons to oxygen. Magnesium doesn't want them anymore.
Wow.
I'm going to show you that in just a minute. It has 8 electrons under, well, let's just do it now. 1s, let's go back to our Hog Hilton like we did yesterday.
Do it right there.
I would, yes ma'am.
I don't get this.
Okay, you gotta just keep watching, okay? If you look on the periodic table for magnesium, how many electrons does magnesium have all total? It's atomic number 12. So how many electrons does it have?
Ma'am?
How many electrons does magnesium have? If it has an atomic number of 12, how many electrons does it have? All total. 12. Okay, so magnesium has 12 electrons. So I'm going to put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's what we did yesterday, remember? What if magnesium gives away 2?
Then it'd be 14.
If it gives away 2, how many does it have in this second level right here? Count those. 8. How many does every element want to get?
8.
8. So that's why magnesium will very quickly say, oh, I don't want you 2. You 2 at the top, I don't need you anymore. I would rather have 8 than 12. So I'm going to give those 2 away. So it will give them away to oxygen. When it gives its electrons away, it has what charge?
A negative?
No, it's giving the positive. Positive 2 because it's giving away 2. The oxygen then has what charge?
Negative.
Negative 2 because it takes 2. So oxygen takes those 2 electrons from magnesium. One is positive charge, one is negative charge. Opposites attract. Since opposites attract, these 2 things will stick together. Okay? And make a compound. So they are together now. Yes, they're a couple. Anyway, never mind. We're going to do it again. Just keep watching. We'll do enough examples, okay? You got to keep paying attention. This is an ionic bond.
Where? Oh. How?
So this is an ionic bond right here. The reason I know it's ionic, there are 2 ways I know this is ionic. I look at these charges. Opposite charges means it's ionic. Always. If I have a positive and a negative, that means it's ionic. The second way I know is because of what type of elements I have. Magnesium is a metal. It's on the left side of the periodic table. That means it's a metal. Oxygen is a nonmetal. It's on the right side of the periodic table. So it's a nonmetal. Anytime you have a metal and a nonmetal, it's ionic. Always. Always.
So the 0.7 don't matter?
No, I don't even want you to think about those numbers ever again because I will not be making you do that in this class.
That's where I
Yeah, when you get to chemistry, you may do that, but for right now, all you need to be concerned with is if you have a metal and a nonmetal, it's ionic. Something from the left side, something from the right side, it's ionic. We'll get to the other stuff later. Let's just understand one at a time. Okay, Zach?
If you have like a sink